Today we're starting chapter 5, so the lesson that we're doing is going to be on section 5.1, and that can be found on page 219. Okay. The title for today is Rational Numbers. Okay. And our objective will be to write fractions as decimals and vice versa. So, objective. Students will write fractions as decimals and vice versa. So that means fractions as decimals and then decimals as fractions, okay? The first thing I actually need to start with is a little bit of vocabulary. Rational numbers, I need to tell you exactly what those are. So let's write down the word rational numbers. A rational number is a number that can be written as a quotient of two integers. So can be written as a quotient of two integers. So let's talk about exactly what that means. First of all, quotient usually refers to division, and then of two integers. What they're really saying is that a rational number, quotient of two integers, would mean that it can be written as a fraction. Okay? So any number that you can write as a fraction would be considered rational. For example, 1/2. That is already a fraction, so yes, of course, that is rational. Okay? The number 5, or any other whole number. Whole numbers can always be written over 1, which means that it could be written as a fraction. Okay? There are also mixed numbers, like 5 3/4, that is a fraction with a whole number, but we could write it improperly, like as an improper fraction, so that would also fit in the category of rational. The other thing that can be written as a rational number is repeating decimals. Okay. Repeating decimals can be written as fractions as well. For example, 0.3 repeating. Okay? 0.3 repeating is really 1/3, which is clearly a fraction. 0.6 repeating, that is 2/3. That can clearly be written as a fraction. So these are some examples of rational numbers. Anything that can be written as a fraction is considered a rational number. Okay? Now, let's go back and talk about what our objective is. Our objective is to write fractions as decimals. So let's work on doing that. Okay? Before we start that, actually, I want to go back and just clarify one thing. There's a picture in your book, which is actually a pretty good picture. And it kind of shows you where all numbers fit. So, for example, let's say we have rational numbers. Okay? Inside of there, we would have integers, because all integers are rational numbers, okay? For example, an integer might be -4, or 8, or 10. Remember how we talked about those can be written over 1, so those would be rational. The other thing is that all whole numbers will also be rational, okay? So just so you can kind of see a picture of it, all the whole numbers will be rational, all integers will be rational, and we also have other things that are rational as well. I told you that repeating decimals are rational, and also terminating decimals. Terminating means that they end, okay? If you think about it, if a decimal ends, you can figure out the place value for it. If you can figure out the place value, you can then make it into a fraction. And I'm going to show you how to do that in a minute, because one of our objectives is to take decimals and make them into fractions. Okay. Let's start with the number 3/8. Okay? The first thing that we want to do today is take fractions and write them as decimals. What we're going to be doing is dividing 3 by 8. That's how you turn a fraction into a decimal. So you're going to do 3 divided by 8. Okay? The decimal point is behind the 3, so I'm going to just move it directly up where it goes. Now 8 cannot go into 3 evenly, so I'm just going to place a 0 there as a placeholder. I don't have any more numbers, so I'm actually going to have to add a 0. 8 goes into 30 3 times, right? 3 times 8 would be 24. I subtract those and I'm left with 6. I have to put in a 0 and drop it down. 8 can go into 60. How many times? That would be 7. 8 times 7 is 56. I have 4 left over. We're going to keep going until either it finishes, which means terminates, or until we figure out a repeating pattern here. 0. Oh, 8 goes into 45 times perfectly, doesn't it? 8 times 5 is 40. We get 0. Once you get a 0, you know that you're finished. And my answer is 0.375. You are going to be doing this by hand, not using a calculator. Okay? Now this is a terminating decimal. Terminating decimals are rational, which makes sense because 0.375 is really 3/8, which is a fraction, which automatically makes it rational. Okay? Let's try another example. How about 5/11ths? So that means 5 divided by 11. I'm going to put my decimal where it belongs. 11 cannot go into 5, so I put my 0 as my placeholder. I add a 0. 11 can go into 50 4 times. 4 times 11 is 44. When I subtract, that leaves me with 6. I drop down a 0. 11 can go into 65 times. 5 times 11 is 55. That gives me 5. Okay. I drop down a 0. 11 can go into 50 4 times. 4 times 11 is 44. Oh, I'm kind of starting to see a pattern. You see how I had 44, and then a 6, and then a 55, and then a 5, and then a 44. Now I have the 6 again. So if I do the 6 again, I'm going to get 5 again. You see how that's going to keep repeating, 4, 5, 4, 5, 4, 5. So what you do is you need to write it with a fraction bar. You take off any extra numbers that you don't need, and then you put the repeat sign up there. That would be called that notation bar. Okay, you put that up there. You don't want to put extra numbers. You always want to write as few numbers as possible. Now this is a repeating decimal. Remember I said repeating decimals will be rational as well, which obviously it came from a fraction, so that proves that it is a rational number. Okay? The next thing that we have to do is work the other direction. I told you we were going to take fractions and make them decimals. Now we have to take decimals and make them fractions. So let me show you a couple examples like that. Okay. For the first example in the book, they use 0.7. That is a terminating decimal, which means it ends. That means that it's going to be rational, so I can make it a fraction. All you have to do is say the decimal out loud. The 7 is in the tenths place value, so this is 7 tenths. So as you write a fraction, you write 7 tenths. And you would be done for that one. Okay. How about negative 3.05? Okay. I know my answer is going to be negative. Negative 3 and something. Okay. You take a look at the last number. This is the tenths hundredths place value, so I'm going to say 5 hundredths. I'm going to write 5 hundredths. And then we do need to do some simplifying, okay? 5 can go into 5 once. Oops, that's hundredths. 5 can go into 5 once. 5 can go into 120 times. So that would be my final answer. So we've taken 2 terminating decimals, which I already told you are going to be rational. And I just proved to you we can write them as fractions which means that they are rational. Okay? How about this one? 0.93 repeating. Okay. They want me to write that as a fraction. Now, these are definitely more difficult. I'm actually going to move this up and give us a little bit more space. If it's repeating, it is rational. So that means that we should be able to make it into a fraction. But we're not going to be able to do it the same way we did the last ones. We can't look at the last place value and just give it a name because it keeps going forever and ever and ever. So here's what the book suggests that you do. Because there are 2 repeating decimals in this problem, they want you to multiply it by 10 to the second power, which would be 100. Here's what they suggest you do. They suggest that you take this and make it into an equation. So x equals. Now remember, if you do something to an equation, as long as you do it to both sides, it's okay to do that. So what they're saying is, because this is 2 numbers that are repeating, let's multiply both sides by 100. By 100. Okay? That means that on the left, we'd have 100x. And over here, if we multiply by 100, remember that moves the decimal twice, we would actually end up with 93.93 repeating, because it still keeps going and going and going. We are actually getting closer to where we want to be. Remember, our goal is to write it as a fraction. So now, how do you get the x alone? This is actually what they do. They subtract 1x from both sides. Now, I'm going to subtract x here, but on this side, I'm going to subtract how much x is worth. X was worth, remember how much x was worth? 0.93 repeating. Now, technically, I did do the same thing on both sides. This side I subtracted x, and this side I subtracted negative, or 0.93 repeating, but those 2 things are equal. So I did the same thing to both sides. Now, here's what that does. Over here, it gives me 99x. Over here, it gives me 93. See how this part's gone now? Now, I've gotten rid of that repeating, which is what I wanted to do in order to get it into a decimal, or a fraction. Now, how do you get x alone? Divide by 99, divide by 99. So x is going to be 93 over 99. And then you just have to decide if you can simplify that. I think they are both divisible by 3. So that would be 31 over 33. So that means that 0.93 repeating as a fraction is 31 over 33. So let me go back through the steps. The first step was to multiply by a power of 10. Now I chose 100 because there were 2 numbers repeating. If there was just 1 number repeating, I would have multiplied by 10. If there were 3 numbers repeating, I would have multiplied by 1,000. You have to do it to both sides. The next step is to subtract 1x. So I subtracted an x, I subtracted what x was worth, and what that did was got rid of the repeating for me. Okay? So then what this does is it leaves me with a fraction that I can simplify, and then I've met my objective. I want you to write down what questions you have, and we can go through the rest tomorrow. You all done? Yeah. Okay, you can.